Assalamualaikum and good morning. So this is the solutions for the previous exercise, which is the mesh analysis. So this is the mesh analysis. First is you have to identify the numbers of loop. So which is in this circuit is consists of 3 loop. Loop I1, loop I2 and loop I3. And then you need to do the KVL for each of the loop. But before that, before you do the KVL, you have to ensure that is it the circuit consists of supermesh, is it the circuit consists of a dependent source, if dependent source, is it a current source or voltage source, current source or voltage source. So first is we need to do KVL at the first loop. So first KVL at loop I1. So we assume that all the voltage at the resistor is positive because you want to ensure that for the loop I1, the I1 is dominant. So it means that when the I1 is dominant, I1 will minus the other currents at the others branch. So the owners of the loop is I1. So this is the voltage that you need to consider. And then we assume that here is positive. So start with the left side, which is minus 10 plus with, here is plus 7 I1 plus with 6 I1 minus I2, which is the adjacent loop, equal to 0. Okay. Then you need to group the equation for I1 and I2. Actually, what you can do is you can see that the current is current I1 is flowing through the 7s and 6. So it means that 7 plus 6 is 13. 13 I1 and then minus 6 I2 equal to 10. And then this one will be equation number 1. Then for the next loop, as you can see that there is super mesh here. How to identify the super mesh? In order to identify the super mesh, it means that when you want to do the KVL at that loop, you cannot find a voltage there. For example, in order to do the KVL at that nodes, you need to times I with the R. As you can see here, there is no R. Therefore, it only consists of the currents. So it means that this is a super mesh, and then you need to do a KVL equation by combining the loop in between the super mesh here. So it means that you have to combine the V at the left sides and then the V at the right sides of the current source, which is a super mesh. Now KVL at super mesh which is you have to combine the I2 and the I3 loops. So start with here. We assume that here is positive. So 6I2 minus I1 plus 10 I2 plus here 6 I3, and then this is the voltage. The KVL is a summation of voltage. So here is 6Ix equal to 0. So 6Ix is a voltage source even though the parameters is current, which is the Ix. You only considers the values of Ix. We not considers the units of the 6Ix. So even though it 6Ix, it is a voltage. Then you rearrange these equations and then you can get the values is 6I1 plus 16I2 plus 6I3 plus 6Ix equal to 0. It will become the second. And because of this consists of the super mesh, so it will have a super mesh equation. Super mesh equation, which is what is 2m. So 2 is equal to I3 minus I2 is equal to 2. Okay, you can see that this is the currents 2m, and then for the left side is flowing from upper to the bottoms, and then for the right side I3 it has the same direction with the 2m. So in order to get the values of 2, same direction minus with the opposite direction. So it's mean that I3 minus I2 is equal to 2. It will become the equation number 3. So because of the circuit consists of dependent source, so it will has a constraint equation. What is constraint equation? Constraint equation is what is Ix. Okay. Constraint equation. So Ix is equal to, as you can see that here is Ix. So Ix same directions minus with the opposite direction. As you can see that the Ix has a same direction with the I1. Therefore, I1 minus with the I2. Okay. Then you have 4 equation that related to the KVL, and then you need to solve or rearrange the equation so that you can convert that to the metric form and solve it using a calculator. As you can see that we can substitute 4 into 2, then the equation will become 10 I2 plus 6 I3 equal to 0. This will be the equations number 5. So you just omit this equation and then you rearrange the equation number 1, 3 and 5 into the matrix 13 minus 6 0 0 minus 1 1 0 10 6 I1 I2 and I3 equal to 10 to and 0, and then you substitute this into the calculator, and then the answer will be I1 is equal to 0.423 m, I2 minus 0.25 m, I3 equal to 1.25 m. So this is the answer for the first question. What is the voltage Vy? So the voltage Vy, what you can or you need to do is by doing a KVL to that circuit. Okay, after you know all the current, so it means that you will know the voltage at each of the element, which is you can know the voltage at 6 ohm here, 10 ohm. So where is the locations of Vy? So Vy location is at the middle of the circuit. So the voltage that related to the Vy is V at 6 10 ohm, and then of course the Vy, and then you need to do a KVL at the I2. Now, you must remember, in order to do the KVL first is you have to decide the flowings of current. So I decide that the current is flowing like this one, and then for this branch is look like this one, and then you must decide the polarities of the voltage for each of the element, and then the KVL. And then for the Vy, the KVL will be minus here, you can see that minus 6. What is the I that flow through the 6 ohm? Because of, I assume that the current is flowing from here, so it means that the I1 minus I2, and then here the I2 plus I2 times with the 10, and then plus with the Vy, and then you substitute all the values into this circuit, and then you can get the values of Vy is 14.5 volt. Okay, so this is the KVL at the middle loop. And what is the power for dependent source? And then the power for the dependent source here, this is the dependent source. So the current is entering your positive, so P is equal to positive I V. The I is I3, and then the V will be 6 Ix. So I3 times with 6, so Ix is I1 minus I2, and then you substitute all the values into this equation, and then finally you can get the values of P is 8.x watt. Okay, so hopefully you can understand the mesh analysis. Thank you.